Today on Capecchi's Corner, we're going to look at the angle of elevation and depression. The angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. So for instance, this is our horizontal line here. There's our angle of depression. It's looking down, looking at a point below the line. The angle of elevation is the angle formed by a horizontal line and a line of sight above the line. So here's our horizontal line, and our angle of elevation, we're looking up. Now one thing you notice is because we're talking about two horizontal lines, one here and one here, those lines are parallel. And so we have a transversal right here. So what happens is the angle of elevation and the angle of depression become alternate interior angles, therefore they are congruent. Let's look at our first example. It says when the angle of elevation of the sun is 78 degrees, a building casts a shadow that is 6 meters long. What is the height of the building to the nearest tenth of a meter? So let's take a look at what we have. We have a diagram here that gives us a good visual. The sun's on the top. We have a 90-degree angle because that's what we're looking at between the building and the shadow, which is on the ground. And we have an angle of elevation of 78 degrees. So I'm going to work with this down here on my other triangle. There's my 9 degrees. I have 6 meters here, 78 degrees, and it's asking for the height to the nearest tenth of a meter. So that's what I'm looking for, the height of the building. So now again, I can use my trig functions. I have 78 degrees, and I know I have opposite and adjacent, so that's going to be tangent. So tangent of 78 is equal to x over 6. So I know x is equal to 6 times the tangent of 78. When I multiply these together, I get 28.2 meters when I round. And that's the height of the building. Our next problem says a forest ranger in a 90-foot observation tower sees a fire. The angle of depression to the fire is 7 degrees. What's the horizontal distance between the tower and the fire? Round to the nearest foot. So I have my diagram. Here's my fire over here. There's the tower. We know that the observation tower is 90 feet. That's marked. And we have the angle of depression up here is 7 degrees. So we have 7 degrees right in here. Now we also know that 7 degrees is outside of the triangle that I want to work with. But we talked about earlier that because I have two horizontal lines here and here, that I have alternate interior. So it actually becomes 7 degrees inside as well. The directions ask for the distance between the tower and the fire, which is x. So again, I have 7 degrees. So I can use my tangent function. So I have tangent of 7 is equal to 90 over x. Notice the 7 degrees that I used was my inside angle because I need to use an angle that's inside the triangle. So I have x times tangent of 7 is equal to 90. Divide both sides by tangent of 7. So I know x is equal to 90 over tangent of 7. So x is equal to 733 feet when I round to the nearest foot. So that's the distance between the tower and the fire. Our next problem states an air traffic controller at an airport sees a plane at an angle of elevation of 41 degrees. The pilot reports that the plane's altitude is 4,000 feet. What is the horizontal distance between the plane and the airport? Round to the nearest foot. So in this case, we weren't given a diagram. So I have a triangle there. So we need to start labeling things. So I know that my angle of elevation is 41 degrees. It's down here looking up. I also know that the plane is in the air. So sometimes I'm not really very good at drawing. So I'll just write the word plane. And the air traffic controller, so the controller is down here on the ground somewhere looking up. The pilot reports that the plane's altitude is 4,000 feet, so I'm going to mark that. Altitude is my height. And I want to know the distance between the plane, which would be from here, from the altitude, and to the airport. So the airport's here, so that's x. So I'm going to use tangent of 41 is equal to 4,000 all over x. So I can take x times tangent of 41 is equal to 4,000. So x is equal to 4,000 all over tangent of 41. And when I round to the nearest foot, I have 4,601. That's the distance from the plane and the airport. In our last problem for today, it says an operator at the top of a lighthouse sees a sailboat at an angle of depression of 2 degrees. If the top of the lighthouse is 25 meters above sea level, what is the distance between the boat and the base of the lighthouse? So now we need to label our diagram. So here's the top of the lighthouse. So again, I'm going to write the word lighthouse. Now we can start labeling our diagram. So I know this is my lighthouse here. And I know that there's a sailboat down here. And there's an angle of depression of 2 degrees. Remember, the angle of depression is out here. That's 2 degrees. And I also know, because this is a horizontal line, that alternate interior angles, that's going to make a 2 degrees angle inside the triangle, which is what I need. And it says the top of the lighthouse is 25 meters above sea level. So that makes this measurement here 25. What's the distance between the boat, which is here, and the base of the lighthouse, which is here? That's x. So I know I have tangent of 2 is equal to 25 over x. So x times the tangent of 2 is equal to 25. X is equal to 25 over the tangent of 2. And that gives me approximately 716.3 meters. That's the distance between the sailboat and the bottom of the lighthouse.